Hi guys. Um, yeah, so I hope you guys are safe with the cold weather. I know when I originally was planning for this, I think you always assume like, oh, when we're off on Friday, that's going to be it. But here we are, another day of it. So I feel like this is always the point as a teacher where you kind of have to start moving along a little bit more, while also recognizing you're going to have to come back together and also make sure everybody's making sense of everything. So we are going to start the next section, which I gave you guys some intro videos on. But yeah, so we're going to take some notes. So if we go in our notes packet that I gave you last week, there was one more page front and back in there where it was the introduction to logarithms. So if you guys want to get your notes packet out, and go to this last page, that's where we're picking up, where it says 6.3 logarithms at the top. So as an introduction to logarithms, we're going to graph y equals 10 to the x power. And then this right here where it says log, that we read that as log, but that's a logarithm. So we don't even know what that is yet. So we're just going to use our graphing calculator to make a table of each of these and graph these, and then we can talk about what we notice. Okay, so if we were to graph y equals 10 to the x power, well, we could make a quick table of values for that, picking different x's and seeing what the y's are. So we could say, for example, if we put in 0, 10 to the 0 power is 1. If we put in 1, 10 to the first power is 10. If we put in 2, 10 squared is 100. Okay, so that's getting really big really quick. If we start putting in negatives, if we put in -1, well, 10 to the negative first power is 1 over 10 to the first, which is 1 over 10. 10 to the negative second, that's 1 over 10 squared, right? It's changing a negative exponent to a positive. We flip it to the denominator. That's 1 over 100. And we see what's going on there. As we go in the negative direction, it's getting closer and closer to 0. So you can plot those points, 0 comma 1, 1 comma 10, way up there. It's going to go up as we go this way. And then as we go negative, we're really, really close to 0. All right, so we have an asymptote there. We could draw that in. Okay, so that's y equals 10 to the x power. Now, we don't have any background knowledge on what y equals the log of x is, but we could use a graphing calculator and type in y equals log of x. Okay, so we go into y equals. We see log on the left side here, okay, where we could hit log of x. And we could pull up the table of values to see what points we get there. So let's pull up our table. What do we got? So at 0, it says error. Okay, well, that's fine. Let's just write that. So 0, we get error. What else we got? At 1, we're at 0. At 2, it looks like we're at 0.301. At 3.477. So something wacky is going on there. If we went all the way to 10, oops, sorry guys. We get 10 at 1. And then why don't we go in the negative direction also? Just to get an idea of what's going on as we go that way. So it looks like we're getting more errors as we go that way. Okay. That's okay. So we probably need to know what's going on as we get closer and closer to 0. But we'll see that as we kind of talk about what's going on as we graph this. So let's graph these points, then we can look at what this picture looks like. So we have at 1 comma 0, we have a point. At 2 comma 0.301, 3.47, all the way at 10, we're here. Okay. What we're going to see is that these are going to wind up being inverses of each other. Okay, whereas we go closer and closer to 0, this is going to go down forever that way. If we're comparing their key features, the x-intercept for y equals 10 to the x power, that had no x-intercept, right? This never crossed, right? If we look at the red graph here, we never crossed the x-axis, versus y equals log of x that had the x-intercept at 1 comma 0. The y-intercept for y equals 10 to the x power was 0 comma 1. Y equals log of x, that did not have a y-intercept. That was none. And then our asymptote for y equals 10 to the x power was at y equals 0. Well, we haven't really seen this before, but this logarithm graph has a vertical asymptote, okay, where this one is getting closer and closer to the y-axis. Okay, so we would call that a vertical asymptote at x equals 0. Okay. So what we're seeing is these are inverses of each other. Remember, an inverse would be a reflection across the line y equals x. So we're flipping it over that line there. Okay. So let's just make a note. They are inverses. So guys, just so we understand, that's the main reason we started with this. Okay. That's not necessarily going to be the question you're going to have to do today. That's just like an introduction. So main idea being when we graph y equals 10 to the x power and graph y equals log of x, we're seeing that those are inverses of each other. And that's going to help us get to our main rule here as we start going between exponential equations and changing them to logarithmic equations in a sec. Okay, but so the main idea being y equals 10 to the x power and y equals log of x are inverses of each other. Okay, we're going to skip the graph at the bottom. So let's flip the page. Okay, so now this is really our main page of notes, what I'm expecting to be able to do today. So now we're getting to what is an exponential equation versus what is a logarithmic equation. So this kind of diagram at the top, I think, is really helpful for you guys to understand how to change between the two. Okay, so if we have this one to the right is also a little bit easier, I think, to visualize. So if we had 2 to the third power equals 8, the same way that an exponential equation always has a base, a logarithmic equation always has a base. It's this little number that goes at the bottom here. Okay, so in 2 to the third equals 8, the base is 2. This to the right is called a logarithmic equation. We would read this as log base 2 of 8 equals 3. So there's still a base. It's the same thing. It's that number that's in front. We write it as a subscript in a log. Okay, so 2 is the base in both of these. Okay, so again, if we were just reading this right side over here as a logarithmic equation, we would read this as log base 2 of 8 equals 3. Now, if you guys watch that introduction video that I posted on Friday, basically we can think of log base 2 of 8 equals 3. If it just said log base 2 of 8, we can think of that as 2 to what power equals 8? Well, 2 to the third power equals 8. Okay. The other way you can think of it is if we're doubling and we wind up at 8, how many times did we double? 3 times. Okay. So we can always take an exponential equation and change it to a logarithmic equation, or vice versa. We can take a logarithmic equation and change it back to an exponential equation. So that's going to be one of the main skills for today. So we look at the example. So it says 2 to the fifth power equals 32. If we were going to change that to a logarithmic equation, again, basically the number in front's our base. So we would say log base 2 of, and now this is where the flipping occurs. Okay, what it equals at the end is going to become, is going to go inside the parentheses of our log, and then that exponent from the beginning is going to go into the equals piece. So log base 2 of 32 equals 5. So the only thing that flips is the location of 5 and 32. Again, like I have down here, log base 2 of 32 equals 5 is how we'd read that aloud. So let's do some more. So log base 4 of 16 equals 2. If we look at C, log base 10 of 1,000 equals x. Last one, E, remember E is that irrational number that we talked about before that came up when we were dealing with compound interest. Okay, so we would write this as log base E of y equals x. And then we'll talk about this way more, but when our base is E, we're going to call that the natural log. Okay, which the natural log you'll see written as ln of y equals x. So log base E, you'll see that written as ln, meaning the natural log of y equals x. We'll talk way more about that, but that's going to be something that comes up a lot. We could also go the other way. So if we're written as a logarithmic equation, could we change it to an exponential equation? So now the base is going to become the base of the exponential equation. So 4, then our exponents, what it equals at the end, to the third power equals 64. Or 3 to the fourth power equals 81. Anytime no base is written, it's implied that there's a base of 10. So if there's nothing written, it's implied we have a base of 10. So we'd have 10 squared equals 100. And then again, anytime we see natural log, that's like saying log base E of 1 equals 0, meaning E to the 0 power equals 1. Okay. All right, what else we got? Let's start evaluating. So it says, if f of x equals the log of x, evaluate the following by estimation, then verify with a calculator. Okay, so f of 1,000. So it's saying put 1,000 in for x in this equation. So really this is saying, what is the log? Again, it's not written, but there's really a base 10 there of 1,000. Okay. So if we were going to rewrite this as an exponential like equation where this is equal to x, this is really saying 10 to what power equals 1,000? 10 to what power equals 1,000? Well, 3, right? 10 times 10 times 10 is 1,000. So our answer would be 3. Okay. We tried another one. If we put 0.0001 in for x, this is like saying log base 10 of 0.0001. So if we change this to an exponential equation, 10 to what power equals 0.001. That one you might have to pull up a table of values for, but that would be the exponent negative 4. Okay, because, I lost a 0 here. Because 10 to the negative first power would be 0.1. So 10 to the negative fourth, if we continue to multiply by 1 over 10s, we're going to wind up with that at when x is negative 4. Okay. Try another one. Square root of 10 going in for x. So we'd have log base 10 of square root of 10. Well, square root of 10 is like saying to the 1/2 power. So log base 10 of 10 to the 1/2 power. So really this is saying 10 to what power equals 10 to the 1/2 power? Well, then it would have to be 1/2, right? Because now this question mark is just the exponent. So it'll be 1/2. Same idea for this last one. Log base 10 of 10 to the 7th power. So we're saying 10 to what power equals 10 to the 7th power? Well, 7, right? So next, some calculator notes. Not everything's going to come out to nice whole numbers. So if it said log base 4 of 37 and we had to evaluate that, basically we're going to take the log of 37 and divide that by the log of 4. Okay, where that's going to be how we can evaluate. So we say log 37 divided by log of 4. We're going to get that answer, because not everything's going to come out to nice whole numbers. The same way where with exponents, we're not always going to have nice whole number answers. Okay. So let's do a little bit more. Evaluate down here. Okay, so now it says log base 7 of x, where we're going to put in these function values in for x. So really we got to find log base 7 of 49. Let's change this to an exponential equation. It's saying 7 to what power equals 49? Well, that would be 2, right? 7 squared is 49. Try another one. If we put in 7 for x, log base 7 of 7. 7 to what power equals 7? Well, 1, right? 7 to the first power equals 7. Log base 7 of 1 over 49. 7 to what power equals 1 over 49? Well, a negative exponent would flip that to the denominator, so our answer would just be negative 2. Log base 7 of 7 to the negative third power. 7 to what power equals 7 to the negative third? Well, that would just be negative 3. Okay. A little evaluating like we did up there. That'll be what we'll conclude with. So if it said find ln of 25, we're going to see there is a button on our calculator for finding a natural log. So we have the log button on the left side here. Right below that it says ln. That's our natural log button. So ln of 25, we can just type that in. 3.218, so we could say it's approximately 3.22. And if we were going to do log base 4 of 1 over 7, we're going to type that in our calculator as the log of 1 over 7 over the log of 4. So say log on the left side, 1 divided by 7, close our parentheses, divided by the log of 4. Negative 1.40. Okay. Last one, again, rewrite it as log of 0 over log of 8. Log of 0 divided by log of 8. Uh-oh, we got an error. So this is undefined. Let's think about why for a sec. Well, log of 0 is saying, remember this is base 10. When it's not written, there's a 10 there. So it's saying 10 to what power equals 0? Well, there's nothing there, right? You couldn't have 10 to some power that equals 0. That doesn't exist. Okay? So that logarithm would be undefined. Okay? We're going to leave off those solving ones at the bottom. So that's where we're going to stop today. From here, you're going to see I'm going to post some practice problems on Classroom with this. So you guys can go on Classroom and find those practice problems, and that's what I'm going to have you guys do next. Okay. All right. Have a good day, and I hope I get to see you guys tomorrow.